put our eyes a lot. So we don't you were so serious. You're 11.
We start talking about the triangles today, then we're going to classify them. Hence the reason this is called classifying triangles. But first, you are going to need to write a definition of what is a triangle. So there are some triangles. I got a green one, a red one, and a purple one. So, what's a triangle? Go.
Regular shape with 3 sides.
Say it again.
A shape with 3 sides.
A shape with 3 sides? Sure about that?
Well, everybody's looking at you, so no one knows.
Don't look at him, everybody.
Look at it.
Okay. Go.
A polygon.
Oh, that's a good start.
With,
That narrows it down a little bit. Hold on, I'm sorry to interrupt you, but could we go back then? If you're going to use the big fancy word like polygon, can you refresh? I mean, I remember because I'm a professional, but they might not remember how we defined a polygon.
a polygon is a shape that has straight sides that don't intersect.
Good, and it's closed.
Yeah.
Okay, great. Okay, so a triangle is a polygon.
A polygon with 3 sides that the angles add up to 180 degrees. Like of all the,
They do.
yeah.
Can you prove that?
Yeah.
Go. Prove it. Go ahead. Prove it. You can't?
Well, it's just something
Okay.
I learned.
Different approach. Is that information needed for the definition?
Probably not.
Because I asked my question that way? Or because you think it's probably not needed?
Well, it's probably not needed if it's polygon with 3.
Okay, so then what would you like to use as a definition?
Polygon with 3 sides.
That's it? Are we okay with that?
Yeah. 3 sides.
Matt, are you mumbling?
No, I just rephrased.
How so?
3-sided polygon.
Wow. Give this guy an award.
Just like the
Give
stick
this
of the
guy an
Caroline,
award.
like yours isn't good enough, try this. Alright, polygon with 3 sides, that work?
Yeah.
Why'd you go with sides?
I don't know. I just kind of went with it.
You could have gone with angles. You've got 3 angles, right?
Yeah.
But you want to go with sides?
Yeah.
Because it's a polygon, many sides.
Yeah.
Question?
Why not both?
Because it would be redundant. It would be repeating yourself. You'd be saying the same thing over and over again.
But aren't angles and sides 2 different things?
They are. But if it has 3 sides, it has to have 3 angles. If it has 3 angles, it has to have 3 sides. Okay, great. Let's move on. We're going to classify triangles by 2 different ways, by sides and by angles. So first of all, we've got that first purple triangle. What kind of triangle is that, Bob?
Equilateral.
Equilateral. Equa meaning equal, and lateral meaning sides. Yeah, like a lateral in football, if you throw it to the side. All 3 sides are congruent. What other kinds of triangles do we have? Oh. Scalene. What's a scalene triangle? S-C-A-L-E-N-E.
Also, repeat that.
The spelling?
Yeah.
S-C-A-L-E-N-E.
Thanks.
You're welcome. Sorry, Colin, what is it?
None of the sides are equal.
None of the sides are equal. And then the other one? I don't want to click because I don't remember what's next.
Isosceles.
Isosceles, correct. And what's an isosceles triangle?
2 of the sides are the same.
Only 2?
Yeah.
Yeah. Okay. Like that?
Yeah.
Okay. Clicker's not working. There you go. We're going to change that a little bit. At least 2 congruent sides. So a common thing that's popped up, well, I think it's popped up, but have I talked about the golden retriever thing yet?
Nope.
No? All dogs are golden retrievers, but not all golden retrievers are dogs?
Oh.
We haven't talked about that before?
Probably not.
You understand what I'm saying, right?
Yeah.
No.
Okay. You don't?
How can a golden retriever not be a dog?
Also,
Well,
not
the way it
all
works-
dogs are
Sorry,
golden.
dude.
All golden
Let me say it
retrievers are
again.
dogs.
All golden retrievers are dogs, but not all dogs are golden retrievers.
You said it.
You
right.
said it
Say it backwards?
Yeah.
Oh, that makes no sense if you go backwards.
Yeah, that's why I was like, what?
All dogs are golden retrievers, but all golden retrievers are not dogs?
Yeah, that's what
Yeah.
you said.
Now, that's completely wrong.
Yeah. 'Cause they look-
I understand your confusion now. Let's back up a second. Hey, have I talked about the golden retriever thing yet?
No.
Yeah.
Just did.
All golden retrievers are dogs, but not all dogs are golden retrievers, right?
Okay.
Same thing is true with isosceles triangles. All equilateral triangles are isosceles, but not all isosceles triangles are equilateral. Got it? So an equilateral is both equilateral and isosceles, but an isosceles isn't necessarily equilateral. Question?
On the test, like if it said classified as triangle and it was equilateral, would you want us to write both equilateral and isosceles or just equilateral?
You could do both, but the priority would be recognizing that it's equilateral.
Okay.
Okay? And then, as Colin mentioned, we've got a scaling with no congruent sides. Okay, good start. Then we've got angles. What kind of triangles do we have if we classify by angles? Any ideas? We've talked about one already.
Equiangular.
That's one. Good. Again, I don't want to click because I don't remember what order I have them in. What else?
What was the first one?
Acute.
Excellent.
Obtuse.
Excellent.
So
Right.
Excellent. So we got right, obtuse,
Cute.
acute, equiangular. Did we miss any?
No.
No.
Straight.
Acute, equiangular. Oh, let's go back, because in case you didn't get that. Acute is 3 acute angles. Equiangular, 3 congruent angles. Then we've got right triangle and obtuse. You can only have one right angle in a triangle. Hopefully that's obvious. What might not be so obvious is you can only have one obtuse angle in a triangle. Then we can combine those sides and angles. So for instance, you could have a right scalene triangle. It's a triangle with 3 sides not congruent and 1 right angle. What combinations, Tommy, don't work?
Me or? Oh. Okay.
An obtuse right triangle.
You're cheating, you're using 2 angles. Give me an angle and a side that doesn't work.
An equilateral right triangle.
Perfect, good. Is that what you were gonna say?
I was gonna say equilateral obtuse
Say again, sorry.
triangle. An equilateral obtuse triangle.
Equilateral obtuse triangle also does not work. Okay, so certain combinations will work, certain combinations won't work. What about an isosceles obtuse? Does that work or not work?
Yeah.
Well, there's no gray area there, you can or can't. Here.
That could work because like in the red color, TA and AC could equal each other.
Yeah, it's pretty much a picture one right there, kind of. I mean, I don't know how close it is, but yes, it would work. What about isosceles right?
No.
Yes or no?
Yes.
Yeah, that would work also. Okay, back here. So we're going to spend some time talking about, specifically about an isosceles triangle. I have the generic isosceles triangle right there. 2 equal sides. It could have 3, but we're just going to look at this one that's got the 2. The two congruent sides are called the two congruent. All right, I'm sorry, I didn't kick you back. And the clicker's not working at all. It's broken. There we go. The two congruent sides are called legs. The non-congruent side is called the base. An isosceles triangle doesn't always have to sit on its base. I could take that triangle and tip it over. The side that it's sitting on, i.e. the horizontal side, is not the base. So common mistake that people make is if I take this triangle and turn it on the side, they think that the bottom thing is always the base. The base is the non-equal side. If that isosceles happens to be equilateral, then that screws everything up. But in a stereotypical isosceles, the congruent sides are the base. And the the congruent sides are the legs, the non-congruent side is the base. These guys down here are called base angles. This guy up here is called the vertex angle because that's called the vertex. They're all vertices, but that's the vertex, capital T, because it's important. Battery's dying. Talked about that already. And then a right triangle. We did this already. Got a right triangle there. Got the hypotenuse. We got the legs. But again, you knew that already. What can you tell me about these two angles in a right triangle? Sarah.
Can you say the question again?
What can you tell me about these two angles in a right triangle?
They are acute.
Good. Anything else?
Are they equal?
Not always. They can be, but not always.
They add up to 90.
Also known as. It's a new sweater. That's really nice.
Complementary.
Complementary. Very good. Okay. Complementary. Why do they add up to 90?
Because the whole thing equals 180.
It does? Are you sure?
I think so.
Can you prove it? Didn't we do this already? Well, go ahead.
No.
Okay. Well, we're just going to pretend we know that. Let's see what Matt has to say.
We can prove it. Because if those two equal 90, and that's a right angle, that means that it's 90 degrees.
Yeah, but you're using what you're trying to prove what you're trying to prove. You can't tell me that these three things add up to 180.
I thought we were saying that those are right.
Okay, so you can't say that these add up to 90 because the whole thing adds up to 180, and because the three things add up to 180, then they must add up to 180. Again, you're using what we're trying to prove what we're trying to prove. Kira?
Well, I don't know if this is correct. I'm kind of just guessing. But like, if you took two triangles and put them together, like two right triangles and put them together, it would make a square, or I guess a rectangle too, if they were different sides. But it would make a square, and then wouldn't each side equal the same? Like each angle would equal each other, which then would add up to 360. So half of that would be 180.
Interesting idea.
Oh, 90,
Interesting idea. Yeah.
You just take the reflection.
Woo. Using all kinds of fancy words. It actually wouldn't be the reflection. If you took the reflection, well, it depends on what you reflect over. Then you'd get something called a kite.
Oh yeah, I knew that.
Yeah. You were just testing, right?
Yeah.
Okay, good. This clicker is dead. Okay, so find the perimeter. Everybody have the picture? Because I forgot to do my pen thing. Are you good? Oh, maybe we're not. This is not a technologically sound day today. You want the back lights on, or are you okay?
This is good.
Good? Nice.
Enough ambient lighting from the outside.
By the way, you need a numerical value for the perimeter, not an algebraic expression. In other words, not 5x minus or 5x plus 1. Thank you.
Same thing we need then for the final answer. So what's the answer?
Seems to be a consistency of 31, yes?
Yeah.
Yep. How do we get that? Trace?
You said 3x minus 5 and x plus 5 is equal to 5x, and then you put x in and then
Now, this one, you really don't even need isosceles triangle knowledge in order to solve the original example. Why did I do it this way? Because I want to talk about problems that are going to pop up when they tell you that a triangle is isosceles. Do not assume if, let me back up. If the sides are not marked congruent, do not assume which two sides are congruent. Again, don't trust the picture. Somewhere in the problem it will say something like triangle PQR is isosceles with side PQ being congruent to PR. Or it'll say isosceles triangle PQR with the base QR. There's got to be some information in the problem, either tick marks, information about the sides, information about the base, that tells you which two sides are congruent in that isosceles triangle. Okay? Don't assume if it's a stereotypical looking isosceles triangle that you can just set those two sides congruent. Does that statement make sense at all? Okay, this one's easy. I marked them both congruent. You set them equal, you solve for x, you plug it back in to find the perimeter. Different problem now. Gave you some numerical values. And I want to know what kind of triangle is JKM. Hopefully you can see the M there, right? Simon, what kind of triangle?
Isosceles.
Why?
Those two sides are congruent.
I think you looked at the wrong triangle.
Oh, what?
Jaguar, kangaroo, mongoose.
Yeah, I looked at LKM.
Which triangle?
LKM on accident.
L as in,
Lion,
K as in,
kangaroo,
I used that one already.
koala bear.
Okay, good. Well, hold on. Koala bear, is that a K or a B?
K.
All right, just checking. I mean, it's a bear, right?
Yeah.
Okay. And M as in,
Mouse.
okay, good.
Um,
So what kind of triangle is jaguar, kangaroo, mongoose?
Equilateral.
Why?
Because because if M is the midpoint between J and L, then that means that JM is 0.75 if L.
Yeah, keep going.
Then if JM is 7.5, then ML has to be 7.5, and if those two are equal,
Or 0.75.
yeah,
Yeah, I know what you meant.
then the tick marks have to be equal, and each side is 0.75.
Good. Which makes it equilateral. Right. Find the values of angle C and T. You can see that right angle down there, right?
Yeah.
Okay, for some reason I put yellow on top of white. I don't know really, I don't know why I did that, but I apologize.
Setup's good. Okay, keep going.
Maybe you gotta get a calculator. Remember kids, not everything in the world gets you nice pretty answers. I'm gonna start with cavalcade of people that you could calculate.
That's awesome.
Alright, what do we got? What's X, Christian?
9.3.
9.3. Anybody else? 9.3? Uh-oh. How did you get 9.3?
I did 3x plus 7 plus 7x plus 10 plus 90 equals 180,
Perfect. Your setup is perfect.
and then I combined like terms and I subtracted 107 from both sides,
180 minus 107 is,
93.
aha, there you go. Check your math there. 180 minus 107 is 73.
Oh, alright.
Alright, so then tell me what you did from there. So now you got, we'll ignore the fact
You
that
divide by 7 on both sides,
Yep.
and then x is 7.3, and then you plug x in.
Mhm. And get your values, right?
Yeah.
What are those values, peoples?
20.9 and 51.1.
61.1.
And again, we cheated and solved that problem using some information that you all know that we don't know, and that is that the angles in a triangle are 180 degrees. We still haven't proved that. Yes, sir?
Wait, where'd you get 107?
90 plus 10 plus 7.
Oh,
Don't we just
I did
set the
I did
angle?
seven.
I did it differently.
I did 7x plus 10 plus 3x plus 7 equals 90.
Yeah.
Yeah.
Combine like terms.
Fine.
Oh.
So he just did 3x plus 7 plus 7x plus 10 plus 90 equals 180.
Right.
Subtract 90 from both sides, it's the same equation. Yeah. So you could either set all three of these equal to 180, or you can add these two up and set them equal to 90, based on what we talked about earlier. Now, using your calculators, I would like you to tell me what kind of triangle we have there. If you were to plot those 3 points on a coordinate plane and do some calculations. Determine if it's a right triangle. Now, looking at the coordinates, you can tell right away that it's not going to be something as simple as having a horizontal side and a vertical side. I did it purposely. What's going to make that a right triangle? How do you know if it's a right triangle? You could even graph it, but if you graph it, are you going to know if it's a right triangle by just looking at a graph? No. Especially since the fact that the points aren't horizontal or vertical from each other. But since the title of the slide is using distance formula, where do you think you would start? Yeah, you probably want to start with the distance formula. And calculate 3 lengths. How long's AB? Say again?
2.24.
What's the exact answer?
Square root of 5.
Square root of? Okay. How long's BC? Or AC, either one.
I think AC is radical 50.
50?
Yeah.
And last but not least,
BC was square root of 45.
is that a right triangle? Matt, are you shaking your head no? It's okay. Worst that could happen is you're wrong, and then we just point and laugh until you start to cry, and then you have to go pet the dog.
Okay.
So you're saying yes or no?
I don't think so.
You don't think it's a right triangle? Okay. Anybody want to jump on the Matt bandwagon here? Yes? You think it's not a right triangle? How many think it is not a right triangle? You only got 2 options, you gotta vote for one. So we got no's. Okay, yeses? Alright. Matt, you're leading this camp. Why do you say no?
I was just thinking adding them all together, and then you get square root of 100.
Is the square root of 50 plus the square root of 45 the square root of 95?
Yeah.
It is?
Like, no,
No.
it's not. Never mind.
Anybody else for the no camp? Why no?
All the sides are equal lengths.
Say again?
All the sides are equal lengths.
And because the sides aren't equal lengths, it can't be a right triangle? Okay. Yeah.
Well, I graphed it to check and it
It's throwing down on the graph.
isn't. Yeah.
All right. Is it obviously not a right triangle if you graph it?
Yeah.
We'll pull out a piece of graph paper.
I made a graph.
Oh, boy. You would not believe how many, I'm not ripping on you, but you would not believe how many times I see this on tests. Okay. Or quizzes or whatever. I'd like to trust you on that, but I'm a numbers guy. Can't just trust.
Wait, are we going for yes or no?
Oh, I don't know. Have we exhausted the no camp? Oh, that's not a good way to start a statement.
Can I explain why it's not a right triangle? Like, are we still on that topic?
We are?
Because if it was a right triangle, then 2 angles would have to add up to 1 angle, and none of them do that.
We know nothing about angles.
You took the words right out of my mouth. Nice job. Don't let me hang it. All right, so let's go to the yes cam. Joanna?
Well, isn't, I mean, if it was a right triangle and you did graph it, then when, like, the square root of 5 squared plus the square root of 45 squared equals 50.
Also known as?
The Pythagorean theorem.
Good. What must be true on all right triangles?
A squared.
A squared plus B squared is
Known as Pythagorean theorem. So if this is a right triangle, Pythagorean theorem must apply. Looking at these three sides, which one's the hypotenuse?
AC.
Why?
It's the longest.
Okay, it's the longest. So if AC is the longest, i.e. the hypotenuse, then we would want to set up our equation as
That works.
the square root of 5 quantity squared plus the square root of 45 quantity squared, whoops, square root of 45, equals the square root of 50 squared. And I'm going to put a question mark over that because we don't know if that's true. What's the square root of 5 squared? 5. What's the square root of 45 squared?
45.
What's the square root of 50 squared?
50.
Does 45 plus 5 equal 50?
Yeah.
Works. That's also why I didn't want the approximate values, because if I take 2.24 and I square it, I'm not going to get 5. I'll get something close to 5, but not 5. Squaring square roots gets you exactly back to the answer you're looking for. What happened on your graph there, Jen?
I'm trying to figure that out right now.
Okay. You'll let us know?
Yeah.
Okay. We're all done. Okay. So you've got definition of a triangle, which we nailed down. You've got the classification by sides. You've got the classification by angles. The trouble is going to come when you start combining those two things. Talking